Welcome to another episode of Ask Better Questions. In today's episode, I'm going to give a little primer on what artificial intelligence actually is. This is something that I probably should have done in one of my earlier episodes, but we're doing it today. So whilst this is a very technical topic, I want to explain it in such a way that you find it as interesting as I do, and yet grasp the basic concepts. So before we get into the episode, I would like to take a moment to thank our sponsor, Colour4 Solutions. I'm a director at Colour4 Solutions, and we provide independent advice on AI implementations for businesses looking to automate any business function. So if you're in the market to automate or implement AI in any of your business processes, be sure to reach out. The links are in the description. So having got the introduction out the way, strap yourself in, as this may get a little technical, but stay with me. I will make it worthwhile, I promise. So what is artificial intelligence? So artificial intelligence, or AI, refers to this simulation of human intelligence in computers and other machines. So it involves the development of algorithms, models, and systems that enable machines to perform tasks that typically require human intelligence, such as understanding natural language, recognizing patterns, solving complex problems, and making decisions. AI systems are designed to learn from data, adapt to new information, and improve their performance over time. So key characteristics of artificial intelligence include learning. So AI systems can learn from data either through supervised learning or unsupervised learning or reinforcement learning, which I will cover in a moment. They can improve their performance by adjusting their internal parameters based on information they process. Reasoning. So AI systems can use logical reasoning and make decisions based on rules and knowledge programmed into them or acquired through learning. Next, we have problem solving. AI can be applied to solve complex problems and optimize solutions. This includes tasks like route planning, resource allocation, and optimization in various other domains. Perception. AI can perceive and interpret the world through sensors and data sources, so enabling tasks like images, speech recognition, as well as natural language understanding. Perception can also be where you've got a self-driving car and it's using sensors to determine what's going on around the car. Natural language processing, NLP, this is the sort of AI that most people are familiar with. AI systems can understand and generate and interact with human language. This is essential for applications like chatbots, language translation, and text analysis. Adaptation, AI systems can adapt to changing conditions and new information, making them versatile and capable of handling dynamic environments. Autonomy. Some AI systems can operate autonomously, making decisions and taking actions without human intervention. Examples include self-driving cars and autonomous drones. Okay? So having said all of that, now we know what artificial intelligence is, let's discuss what machine learning is. Now, machine learning is a subset of artificial intelligence that focuses on developing algorithms and models that allow computers to learn from data, make predictions or decisions without explicit programming. There are several different types of machine learning, each with its own characteristics and use cases. The main types of machine learning are supervised learning. In supervised learning, the algorithm is trained on a labeled dataset where both input data and corresponding correct output data, which is the target, are provided. The goal is to learn a mapping function for each input to output so the algorithm can make predictions on new unseen data. Common use cases include classification, so email spam detection, and regression, so predicting house prices and things like that. Then the second type would be unsupervised learning. So unsupervised learning involves training an algorithm on an unlabeled dataset where only input data is provided. The algorithm seeks to discover patterns, structures, or relationships within that data without any predefined targets. So common use cases include clustering, so grouping similar data points, and also simplifying complex data while retaining essential information. So the third type is semi-supervised learning. So semi-supervised learning combines elements of both supervised and unsupervised learning. It uses a data set that contains both labeled and unlabeled data, and the algorithm leverages the labeled data to learn and generalize patterns from the entire data set, so both labeled and unlabeled. Semi-supervised learning can be useful when collecting labeled data is expensive or time-consuming, or a lot of labeled data is not available. There's reinforcement learning. So reinforcement learning is used for decision-making tasks in an environment where an agent learns to take actions to maximize a cumulative reward. So the agent, so to speak, interacts with the environment and its actions influence future states and rewards. So reinforcement learning is commonly employed in applications like game playing, robotics, and autonomous systems. Then we've got what we will delve into in a moment, deep learning. Deep learning is a subfield of machine learning that focuses on neural networks with multiple layers, so deep neural networks, etc. It excels at automatically learning hierarchical features and representations from data, making it suitable for tasks involving complex patterns such as image recognition and natural language understanding. Examples of deep learning architecture include convolutional neural networks, or CNNs, for images, and recurrent neural networks, or RNNs, for sequences. Sixth is supervised or self-supervised learning. So self-supervised learning is a subset of unsupervised learning where the model generates its own targets from the data, effectively creating its own supervised learning tasks. It's often used in pre-training models for downstream tasks such as natural language understanding or computer vision. There's transfer learning. Transfer learning involves training a model on one task and then using the knowledge gained to improve performance on a related but different task. So this approach is especially useful when there's limited data for a targeted task. There's ensemble learning. Ensemble learning combines predictions from multiple machine learning models to produce a more accurate and robust final prediction. Techniques like bagging, boosting, and stacking are commonly used in ensemble learning. Those terms are not important right now. We can delve into that in a future episode. Then there's also anomaly detection. So anomaly detection is a type of unsupervised learning focused on identifying data points that deviate significantly from the norm or expected behavior. It's used in applications like fraud detection and network security. A lot of government agencies, tax offices and the like are interested in something like anomaly detection. So these different types of machine learning algorithms and techniques offer a wide variety of tools to address various problems and tasks in fields such as data analysis, pattern recognition, decision making, those sorts of things. The choice of which type to use depends on the specific problem, available data, and the desired outcomes. So it's on a use case basis. This is why you need to be speaking to people that know these sorts of things. But how do we do deep learning? And, how does deep learning and neural networks fit into this picture? So deep learning is, as I've said earlier, a subset of machine learning that focuses on artificial neural networks with many interconnected layers, also known as deep neural networks. So these deep networks are capable of automatically learning hierarchical representations of data, which makes them particularly powerful for tasks that involve complex patterns, such as image recognition, natural language understanding, and speech recognition. Deep learning has revolutionized various fields and has led to significant advancements in AI. So here's an explanation of deep learning with some examples. Okay, so you've got deep neural networks. So deep learning is it's characterized by deep neural networks, which consist of multiple hidden layers between the input and output layers. So if you think of it in terms of, and we will cover this in a moment, neural networks having an input layer, an output layer, in the middle is a bunch of hidden layers. These layers allow the network to learn increasingly abstract features and representations as data passes through them. So we've got, I suppose, an example would be image classification. So convolutional neural networks, or CNNs, as I mentioned earlier, are types of deep neural networks used for image classification. They automatically learn features like edges, textures, and object parts at lower layers and combine them to recognize complex objects and scenes. If you've got a Google photo album, it knows and has classified your beach photos automatically into a folder called beach photos or beach, because it recognizes the background. It knows these photos have a background of a beach. Those sorts of things are uses for a deep neural network use. Recurrent neural networks, so RNNs. RNNs are deep learning models designed to handle sequential data, such as time series, text, and speech. They have loops that allow information to be passed from one step to the next, making them suitable for tasks that depend on previous context. The dog bit Johnny, Johnny bit the dog. The data is the same, but the order and sequence is important, because otherwise you can't understand those languages correctly, or the meaning of the actual phrase. RNNs can be used for language modeling, where networks learn to predict the next word in a sentence based on the preceding word. Now, this is a fundamental task for text generation and speech recognition. Long short-term memory, or LSTM networks. LSTMs are a type of RNN that are particularly effective for handling long sequences and mitigating the vanishing gradient problem that plagues traditional RNNs. So we will delve into this in future episodes, but LSTMs are often used in automatic speech recognition systems where they can understand and transcribe spoken language with high accuracy. So there are a lot of programs out in the market at the moment that will automatically take notes and minutes of meetings. So you can have your conference call, everyone on the call can speak freely, and the system in the background will create the minutes of the meeting. It will do that using an LSTM. Transformers. Transformers are revolutionary deep learning architecture for sequence-to-sequence tasks that rely on attention mechanisms. They have enabled breakthroughs in natural language processing and understanding. So examples, models like GPT, generative pre-trained transformer series, so ChatGPT is a good example, and BERT, bidirectional encoder representation from transformers, have significantly improved machine translation, question answering, text summarization. A lot of people's exposure to AI, as we understand it at the moment, is transformers. I think there are 6, so what was the 5th one? All right, generative adversarial networks, or GANs. That's right, GANs. GANs consist of 2 deep neural networks, a generator and a discriminator. These are trained in opposition to each other. So GANs are used for generating data that is similar to real data, making them invaluable in image generation and data augmentation. An example of a GAN, it can create realistic images. So if you think Midjourney, stuff like that, those image generation software, generally GANs. Reinforcement learning, that was the last one. So deep learning is also applied to reinforcement learning, where agents learn to take actions to maximize reward signal in an environment. So gameplay. Deep reinforcement learning has been used to create agents that excel in games like Go, chess, video games, those sorts of things. Now, these are a few examples of how deep learning is used across various domains. Deep learning models show remarkable capabilities in capturing intricate patterns, which lead to significant advancements in AI applications. So The ability to automatically learn features from data rather than relying on handcrafted features is one of the key strengths of deep learning. Okay, so we understand deep learning now. Well, albeit it's very jargon-filled, but CNNs, RNNs, we understand deep learning at a broad base. We will delve into that in future. So what exactly is a neural network? All right, so neural networks are a class of machine learning models that consist of interconnected artificial neurons organized into layers. Now, I've already said there's an input layer and an output layer. There are multiple layers in the middle, which are typically hidden layers. They're designed to process data, learn from it through training, and make predictions or decisions by mapping input data to output data. So a high-level explanation of neural networks as they relate to AI. You've got neurons and layers. At the core of a neural network are artificial neurons known as nodes or units. Now, these neurons are organized into layers with an input layer, one or more hidden layers, and an output layer. The input layer receives raw data, such as a pixel value from an image or words from a text document. Hidden layers process the data by applying mathematical operations to the input, while the output layer produces the final results or predictions. So weights and activation functions, all right? So each connected neuron is associated with a weight, which determines the strength of the connection. These weights are initially set randomly and are learned and adjusted during the training process. So activation functions are applied to the weighted sums for inputs at each neuron, and they introduce a non-linearity to the network, enabling it to model complex relationships in the data. How does it do that? Well, feed forward and back propagation. So feed forward is forward propagation. Basically, during the feed forward process or phase, data is passed through the network from the input layer to the output layer, with the weights and activation functions applied at each step. Typically, you will set these things up with randoms, which will not be fixed, but they will be randoms, and they will be fixed for the period of training. You'll put in input data and you'll have output data. You will compare your output data to your input and see whether or not you hit, and typically you don't. And then you will adjust the settings inside of the hidden layer, the hidden neurons, to adjust it to get it closer to your data set than where it should be. Back propagation is the process of updating the weights used by using gradient descent to minimize that error. Now, this technique adjusts the weights in such a way that the network becomes better at making accurate predictions. So training and learning. Neural networks learn from labeled training data through iterative training, and network performance improves as it adjusts its weights to minimize errors. Now, training data is usually fed through the network multiple times, and this adds significantly to the time it takes to train these models. So neural networks with multiple hidden layers, like deep neural networks, have gained popularity, giving rise to deep learning. Now, deep learning models are capable of learning hierarchical and abstract representations, making them suitable for tasks like image and speech recognition. Now, neural networks have been used in various AI applications, including image recognition, natural language processing, recommender systems, so neural networks that are employed to make personalized recommendations for products or content, and game playing. So deep reinforcement learning has been used to train agents that excel in games, as previously stated, like Go and chess. Basically, in summary, neural networks are the building blocks of AI, or modern day AI. There are still, like I said at the start, many different machine learning methods. Neural networks are one of those tools, a particularly good one, and a particularly interesting one and topical one at the moment. Neural networks serve as a powerful tool for processing and learning from data to make decisions and predictions. They have revolutionized the AI field. They've enabled the development of sophisticated models that can perform tasks that were once considered extremely challenging for computers. So at the risk of this episode going well over time, I intend to go over each of these topics in future weeks, so we can delve deeper into exactly how these ideas work and why you should be as excited as I am about neural networks, deep learning. That said, the limit of neural networks, or the limits of neural networks, are time and data, predominantly time and data. It takes enormous amounts of both time and data to effectively train these systems. Now, there are other limitations such as computing power. That is coming down in cost over time. However, if you're interested in what AI can do for your business, and maybe neural networks aren't your thing, but typically if you have a problem to solve, there are multiple different AI tools and automations that you can put in place to actually solve these issues. But if you are interested, please reach out to us in the links in the description. If you like the podcast, leave a rating and review and subscribe so you don't miss any episodes. I'm Peter Adams, and I'll be here next week to ask better questions.